Assalamu alaikum. My name is Sabah Maqsood and I am currently doing mechatronics engineering from A University Islamabad. And I'm going to show you my lab tasks of microcontroller and embedded systems. My lab 6 task was to take input from one controller using hex keypad and transfer it using UART, SPI, I2C protocol to other controller and display it on LCD. And I have done this task on a UART, SPI and I2C. So I will show you my lab tasks as well as this was my circuit, and this is, as you can see, this is hex keypad. This is my master controller, and this is my safe controller, and this is LCD. First of all, I will tell you what is SPI. So basically SPI stands for serial peripheral interface, and it is basically a serial communication protocol which devices are either slave or master. So basically it works that way. It is a full duplex communication and it consumes less power, so that's why it is efficient but less efficient than I2C. So basically this was my circuit for SPI, and I've already uploaded the hex file. I've uploaded master hex file here and slave hex file here. So I will run my simulation, and when I enter 0, 0 will be displayed on LCD. When I enter 5, 5 will be entered on my it will display 5 on LCD. When I enter 3, it 3 will be displayed on LCD. So this is how my simulation is working, and it is working absolutely fine. Now I will show you my codes in Atmel Studio. So this was my master. As you can see, MSI, MISO, so these are basically my pins defined for SPI. As you know that MISO stands for master in slave out, MSI stands for master out slave in. So that's how it works. So basically first of all I've defined its pins, and then I have written the code and defined it for the and made arrays for the characters which I will enter on hex keypad. And basically this is my whole code in which I have defined first half of port B as input and other half as an output. So that's why I've used F0 and 0F here. So I'm reading the input from port D. I That's why I've connected LCD with pin D as I have shown it on in simulation. So basically I'm comparing values and search for hex key pressed, and then whatever character I press on hex keypad, it will be displayed on LCD. So this is how it is working. So this hex numbers is defined for characters which I will type in LCD. So this is my slave code, and I have used LCD library for this, uh, and I have called LCD library here too. I've initialized same as before here. This is ISO and SP. This is my input pins for SPI, and same I have written slave code like this. It is too short and was easy to code. So basically I have just used slave code to be connected with master. So that's it is taking data from master, and basically uh, this data is going to LCD. That's why I've connected these three pins here, and it is taking data from here which is connected to master. So this is how my SPI is working. So as you can see, my next task was on UART. So first of all I will let you know what is UART. So it is basically universal asynchronous receiver or transmitter. So that's why, like SPI or I2C, no master or slave is involved in UART. It's just there's just receiver and transmitter. Receiver receives data and it transmits it to transmitter. So transmitter transmits data to receiver, and basically these are the main features. It works in full duplex operation, and this is how it works. So basically, since it is written here also that there is no master and slave in the micro, show you my simulation on UR. So basically and it receive data from the and it will receiver and then receiver will basically the simulation is working. One, it will be displayed when I on LCD. When I press 3, it will be displayed on LCD. It's how the simulation. Now I will show you code, and I have also used in here. I have defined of whole port B as an F when use 100 by using enabling reception and basic define trans the correct keypad. So this is how my SPI UART is working. So now I will tell you about iSCSI. So it is same protocol as SPI and IUART, but more efficient than both. So basically iSCSI is used for communication between parts up to 127 participants, um, and basically it has different condition bits and different pins, as well as you can see in SPI. So basically I will show you my simulation first. So as uh, as you can see that this simulation is used for iSCSI. I have already uploaded the hex keypads. So basically it is same as before, as I used for others protocols as well. And whenever I enter 0, 0 will be displayed. Whenever I enter 2, 2 will be displayed. So basically this is how my simulation works. And now I will show you my master and slave codes. And here in master code I have not used any LCD, and I have defined my own functions as in master read address. That's why. So I have given array for characters which I will display on functions, sorry, which I will display on LCD. So it is same as I have used in others protocols as well. So I have written data, and I am taking reading input from port D, and I'm comparing values. And as you can see, these are the hex values which I will press on hex keypad, and it will be displayed on LCD. So basically this is my slave code, and here I have used LCD library, and I have defined functions and already in library. So I have directly called some functions in here. As you can see, these are the pins which are used for iSCSI, as I told you before, as MOSI was used in SPI. So basically I've displayed this data received on LCD display. So this was all for my, I've defined functions and I've displayed values. So basically this was all my for lab 6. Thank you.